Hey, so in this video, I'm going to build a minimal coding agent using OpenAI Agents library in Python. So if you haven't come across this, OpenAI released this Python library so that it allows you to build like multi-agent kind of flow with tools, handoff to different agents, and you can also apply all sort of agentic patterns like orchestrator. Yeah, I will be covering all of these, not all of these, but most of these things which might be required while building our coding agent. So I think it's probably going to be a multi-part video where this is the first video and my first attempt to build this thing. And let me show you what I am thinking about. So I'm thinking to have like, let's say this is my terminal. I have some kind of app here. So why is it do? Okay. So this is a terminal app. Um, and I can provide this thing tools, access to tools such as file system so that it can edit like files, make changes, read files, read the code, etc. I'm not able to expand this. Oh my god, it's yeah. So it should be able to like kind of read the file, um, write the code, and it should have some Git tools so that it can do some sort of Git diff, analyze, pull request. Yeah, I think write, delete, and delete as well. So right now, I think we'll definitely need these kind of tools. So the terminal CLI could be, I'm naming this Gen. Uh, so actually, it can be similar to Cloud Code as well, like where you have an input and then the agent will work. So it can be like human message, then AI action plus message, either of them. So this is how the UX would look like, the terminal UX. Yeah, so let's do this. So I have this Jupyter notebook. So first I will be just going through this project and kind of show you what are different components in this agents library and how to use it. And if time permits, we'll like build a tool and required to build the agent. So let's go to the core concept agents. So agents are the core building block in your apps. An agent is a large language model configured with instructions and tools. So your agent has a system instruction, which is how you will tell the agent how it's going to act. So for example, here, always respond in haiku form. You can also provide the model and you can provide your agent access to some tools. And in this case, the tool is a get weather tool, which will basically, it's a mock tool which basically takes the name of a city and returns a string um, which contains the info about the weather of that city. You can implement you can update this function to kind of use some API and return a real weather, like real time. So let's just copy this and paste in our notebook. We will have to install this library though, so you can do pip install OpenAI agents. I already have done that, so yeah, it's already installed. So I'm just going to run this. And how do I run this? So, okay, yeah, looks like they should have the full code here for people coming first time, but okay, let's copy the code from here. Probably I have already defined my agent. So to run the agent, we first define the agent, which basically contains our system instruction and the model and tools. Next, we create a runner. So to create a runner, we just import runner class from our agents, OpenAI agents library. Then we do runner dot run sync. We pass our agent there, and yeah, this is our input, like the human message. So as an user, I will type write a haiku about recursion in programming. View this event loop is already running. I think I need something to run this async code in my Jupyter notebook. So I think you probably need to install Nest.io. How do I use this? So yeah, this is cool. So this kind of error, I think it comes from like async when we mix like async IO loops. So I think in Jupyter by default you can do async await. I haven't looked deep into it, but probably Jupyter already runs a sync loop, and OpenAI is also trying to run another loop. So that's why we got that error. But we can disable this thing for a few seconds, and we will enable this when we really need it. Snooze for 1 hour. Yeah, so you can see the response recursive mirror call echoes and decode patterns, loop dances without end. So to use an agent, you create the agent, you create a runner to actually run the agent. Um, yeah, which makes sense. So let's go back to the documentation here. Handoff example. So what's a handoff? Yeah, so let's say you have multiple agents, and in this example, a Spanish agent, uh, another example is English agent. And there is a triage agent, which basically, based on the user input, it will kind of switch to a spatialized agent. So if a user talks in English, it will automatically switch to this agent. And if the user talks in Spanish, it will switch to Spanish agent. So let's also try to run this. So yeah, we can, actually we don't main dot main function here. Yeah, so we have a Spanish agent, English agent, trial agent, and we when we create the runner, we only add our triage agent because this is our main agent. So when we provide an input, our input will go to the triage agent, which is our main agent, and then that will automatically switch to either one of them based on our input. So let's do this. So you can see the response came in Spanish, and it switched to the Spanish agent. I think it would be nice to see how it's switching. So for that, I think there's a nice example which you can use here. Let me find that. Cool. So this is the same code which we saw earlier. We have Spanish agent, English agent, and a triage agent. Now we are going to stream the results, and the streaming result allows us to see each of the moves that an agent makes. So we can filter the events by type. For example, if there is a change in agent, so if the agent changes from triage agent to Spanish agent, we can catch it here and print that. So you can see that it first started with triage agent and switched to Spanish agent based on our input message, and then it printed the same thing. It printed an output in Spanish. If we run this and let's say, how are you? It will switch to English agent. Cool. let's add one more agent here, a Hindi agent, which is a language of India. So I'm gonna type Kaise ho, which means how are you? So it should switch to in Hindi. That's excellent. मैं ठीक हूँ आप कैसे हैं? Which means I'm well, how are you? Awesome. So now we have learned that how to use agents and how to hand off to a specialized agent. And how this is going to be useful is we are going to build a coding agent. So when we ask a coding agent to, let's say, optimize a code, a module, so we can easily, based on the coding language, switch to a Python specialized Python agent or the JavaScript agent. So I think this is going to be very helpful there. Also, if let's say if you want to switch to, for example, GitHub agent to push, which has capability to like push the code, pull the code, or like create a pull request or do those kind of things. So we can have a specialized agent for different tasks, and then we can have a main agent sitting interacting directly with the user. So a public agent, which triage and kind of a manager, like which you go to, which you tell something to do, and then it allocates the task to specialized agents. So now takes like so now let's take a look at functions. And it's exactly what it sounds like. It's basically function calling. So I have a function called getWeather, and it basically, if I run this, it will tell me the weather in a particular city. So if I change it to rainy, the output will be rainy. So how it works is I have an agent which basically has access to a tool called getWeather. When I send an input, what is the weather in Tokyo? It checks if it has access to a tool which can help it get the weather information. Then it makes a call to the tool and uses the response of this tool to formulate the response to the user. So I think in our case, we are going to use something like list directory or something. Um, so let's return a dummy kind of value here. src or list or just list. actually ls. So in this case, ls is kind of quite vague, and the agent would really be like, so right now ls is quite kind of quite vague, like it might be difficult for the agent, for the llm to understand what does ls do. So we need to put into the context of the llm that this tool can basically list the files in the current directory. So we can add something like list files in current directory, or you can have like a very elaborative name like list files in dir. So you can do both. Like you can also override description. I think it might also take docstring as description, but yeah. Um, so if I do what files do I have, it should give me src and pyproject.toml. Cool. Seems like it used my tool to format the final response. Let me check if we should cover anything else here. Cool. And one good thing about this agent framework is that you can have multiple LLM providers. So I think OpenAI has integration for Light LLM, which gives you access to any LLM API. I think it was somewhere, but yeah, we can come to that a bit later on. Cool. So let's try to build our agent now. Let's create everything. Don't need this. Delete this. Yeah, delete this. Let's restart the kernel so that we have a fresh environment. So I'm just going to use some of our previous code to modify some stuff. Yeah, so let's build some tools first. Our first tool is going to be a read file. We have to, yeah, provide these tools to the agent or LLM. So read file, which takes the path of the file and return a new file. Return the content of the file. So actually, let's try with our first function itself. So read file. I will update the instruction. You are an expert coding agent who can read and optimize code bases. So let's also input this thing. So let's do something here. Hmm. So it was able to read my file helloworld.py. So it was able to make the tool call and read the code. So it says remove the import of numpy since it is unused. The add function is already minimal and efficient. If your file had a specific area you're concerned about, let me know. So I think now we'd also like the agent to write to the file and basically update it. So let's give it access to write. So write file on to upwrite and code. So we'll update the path with the code, the new code. Guess we can just return true here. I just done. Okay. So let's give our agent access to write file and let's see what happens. And for printing, let's import rich for a nicer print. It was really shitty. I guess this should get rid of, which is print. Okay, so let's see if it really updated our file. No, it didn't actually. So it lied to us. Optimize and update. Yeah, so it read and updated the file. Nice. That's amazing. So now we have a really basic coding agent which kind of it can read a file, make the changes, and update the content of the code. Cool. So that's amazing. Let's see what else it would plan. Yeah, I think we'll come to get a bit later on when we have like more expert kind of coding agent. So I've created this very simple um, repository called ZeroZen, where I'm kind of putting some small LLM based like code snippets, like for example, this one. It basically converts a Pydantic object to XML. You can find it in my GitHub account. It's called ZeroZen. It's open source. It's public. You can just clone it and uh, make the changes for yourself. But I have added the CLI using Typer, which is an open source library. Um, it's based on Click. I think it's built by Sebastian, who is also creator of Fast API. So I have this small CLI command called zeros and chat, and what I'm going to show you how to build a CLI as well. Accidentally, I disconnected. Yeah, so I'm going to show you how you can create a CLI as well. So to create a CLI, you can import Typer, which is an open source library for basically creating terminal interface, not really like you can create CLI just with Python without any open source or like without any library. So you can just use rparse, pass the user input, but it just adds some nice UI to your CLI. So yeah, so if you see, if I type Zen, it just prints away like nice kind of message, like it has completions and everything. So let's add a code.py file here and import typer app is equal to typer. Yeah, and then here we can have something like coding agent. It's a while loop, takes an user input. So we can use something like rich here from rich.prompt import prompt user input let's copy our code from the notebook here. We'll later organize the notebook like this code base to be in a nice shape as well. So we can do something like sync io dot run coding agent. Need this. We'll need to import a sync io. Cool. So we basically copied our code and created a typer app. So for that, you just import typer, we created a function which basically runs in a loop, asks user for input, and then um, just run the just send the input to the agent and prints everything like how we are doing in Jupyter Notebook. And then we have this command function here, which basically runs our coding agent in an async IO loop because we are using async IO here. I guess we can change that, but yeah, let's continue this. So now I'll just import that so that I can connect it to the rest of the command. So app.code. Yeah. And now if I type Zen, I can see command. Actually, it should be named as code. So Zen code. Okay. So a coroutine was expected got a function. It has to be called. That's so weird. Okay. Where did I mess up? A sync IO.run cannot be run from a running event loop. Okay, so let's see how I've done it here. I don't really remember. First things, let's do this. Async IO.get running loop and really. Let's ask her. So actually, why do we not ask our agent in the notebook? Let's try that. So I'm getting loop already running error in, I'll have to specify because it doesn't know how to navigate there at the moment. Then 0/code.py, and it wasn't able to access it. Okay, because Jupyter is in a different root folder. Really? Can it not? What's my working directory? It seems like I have the name of that weird. So let's see. Instead of using you can modify it due to passing at run, I think this is what I had initially, but let's update to async io.run. Still get the same error. Can I do this? It doesn't support, typer doesn't support async IO. So let's try to put the whole error trace to our agent. Let's see what happens. Oh, it seems like it was some rich-based error. Interesting. The prompt wasn't working here. I'll check why that was the case. So let's see my PWD first. Can we not go that way? Okay. Cool. So seems like it's working. We'll do more optimization and we'll add more tools and create more agents so that we can have specialized agent for different kind of things like error analysis that you saw we were trying to do right now. Um, so we'll create a multi-agent framework and try to replicate something like similar to Cloud Code, but that's it for now. We'll do something like this again in the next episode.